All right, Kate, and this one here is a little bit more complicated and has a few more steps. So let's just keep in mind, first of all, the formula that we're trying to use to find the area, which this particular problem wants us to do. We're finding the area of a regular polygon. Regular means that all three sides are the same measurement. The only problem we have here is in looking at this big triangle, I don't even know one of those sides. The only measurement that's given to me is the apothem. So we have to figure out a few more steps that we can use to get us to actually figure out the area of this regular polygon. All right, so let's go ahead and write the formula, though, for that up here. So the area is supposed to be, remember, the apothem times the perimeter. So I need the perimeter, which means I need a side measurement. If I can figure out one side, then I can figure out all three, right? Because they're all three the same. All right. Let's erase some of this. All right, so we're going to do a few things here. I want to kind of go back with you and remember some things that we talked about the last time that you were over here for some tutoring. We had some rules from 7.4. We're going to use one of these sets of rules here, but we have to figure out which one we're going to use. So the first thing that I want to talk about is the fact that if it's a regular polygon, then we know all the sides were equal, remember? So that means it's an equilateral triangle. If it's equilateral, then we automatically know that it's equiangular, which means that all of the angles are the same measurement. So that means all three of these angles are the same measurement. So what would that be? You know that all three of them have to total 180. Divided by 3, that's 60. So we know that each one of these is 60 degrees. Okay, you're probably wondering why I need to know that. Well, watch what we're going to do here. We're going to go back to what I showed you in the very first problem today. First, let me just erase a couple things we're not going to really need here. Well, let's keep in mind, we know they're all 360. I don't want a whole lot of writing here. It gets a little bit confusing. Remember I showed you that we could break these polygons up into three, or however many triangles you can make in there. You go from that center point to each vertex. So you can see here that I've created 3. I'll do them in different colors so you can see them. Triangles, but they're all 3 the same. Okay, so I have 3 triangles here. They're all 3 the same. I know in a way they don't really look it, but they really are. Okay, so I've got those to think about. And I just really only want to focus on one. And I want to focus on the one where I see the apothem over here. So let's focus on this triangle that you see. I'm going to highlight it in yellow. We're going to focus on this one. Okay, now, the reason I want to focus on the whole thing is because I want us to think about this line coming down here from the center point of my triangle. It's acting as a bisector in this angle right here, which means it's cutting it in half. And remember, originally, that was a 60-degree angle. All right, so if it cut it in half, what is this angle right here going to be? Hopefully, you're saying 30 degrees. And that's perfect. So we have a 30-degree angle here. Now I'm going to break this out a little bit further here. And I'm going to make just one of these triangles out of that one there matter. Okay? Let's put this back over. Okay, I only want to focus on half of this triangle inside here. Hold on. My app is so sensitive. Sometimes when I write, these things come up and I have to hit buttons to get out of it. All right, there we go. All right, so in this little triangle to the right that I've highlighted in yellow, we want to focus on that one. So you'll notice we have that 30-degree angle. We also have a 90-degree angle because you can see that right angle right there. So what must this angle right up in here be? Hopefully you're saying that would be 60 degrees. So we have a 30, 60, 90 degree, 30, 60, 90 triangle here. So I'm going to write that right here, 30, 60, 90 right triangle. Now go back to the sheet I sent you last week. Here we have a 30, 60, 90 triangle right here. And we have some rules that we can take a look at here. We can figure out a leg measurement, because remember, in this formula that we have, that we're trying to use the apothem and the perimeter to find the area of the entire big, huge triangle, the original triangle that was given to you in the problem, I got to have some measurements, and I don't have them. I need to figure out these three sides, remember, on the exterior of the big triangle. You can see me doing those in blue right now, okay? Without one of those sides, I can't figure out the problem. So I have to use some of the other knowledge that I have in order to find that. So let's pull out, I'm going to take that little yellow triangle, and I'm just going to draw it right here. So we can identify our short side and our long side. So here's the right angle. We know that the apothem, which is right here, is 4 times the square root of 3 over 3. And what I really need to figure out is this side right here. Okay, that is the long side. You can tell that by looking at that triangle, and you also know, according to where your larger angles are, which sides are actually smaller and which sides are larger. All right, so knowing all that, I'm going to erase some of this out of the way just because we don't really need it, and it becomes too much junk around here. So let's see if we can get rid of some of that. Let me just focus on this. So what we're trying to find, look over here at the big triangle, we're trying to find that little side right there. Okay, so let's look at this paper and see what can I use here. I need the long side. So let's use this part of the rule. The long side equals, if we take, or they call it the leg, we'll call it the leg because that's what I called it before. Leg, side, it doesn't really matter, but the long leg, in order to find the long leg, we can take the measurement of the short leg, remember this, and multiply it by the square root of 3. I got that right over here. Okay, so let's just fill in what we know. Okay, we're looking for the long leg. What's our short leg? Let me highlight it right up here. The short leg is 4 times the square root of 3 over 3. And we're supposed to be able to multiply that with the square root of 3. I'm going to put that over 1 just so I have a denominator there. And that will give me the measurement of the long leg. Before I move any further, though, because I know I've already figured out the problem and I know what that long side's measurement's going to be, and it might throw you for a minute to think, how can that be the long side when I have this measurement up here that looks almost, the measurement itself, when I look at the numbers, I think, I wonder if that's going to be, that my long side's not going to really be in the right proportion. So what is 4 times the square root of 3 over 3? Just kind of in your mind, get an estimate of that. Well, if you actually took in your calculator and figured out what the square root of 3 is, square root of 3, I wrote it down somewhere. Now I can't find where I wrote it. So I'm going to go back in and do it. To turn my iPhone sideways. So the square root of 3 is actually 1.73. So if I took that and multiplied it by 4 and divided it by 3, the measurement of this side in decimals is really only 2.31. Okay, so just keep that in mind, because I think when you see the measurement of the long side, you might think that doesn't make sense. But it does make sense, because this small side is actually being divided into thirds, because that denominator is a 3. All right, so let's go ahead and figure out the long legs measurements here. All righty, so I have so 4 times the square root of 3 times the square root of 3. Remember, the square root of 3 times the square root of 3 is actually the square root of 9. And the square root of 9 is actually 3. So I'm going to take 4 times 3 and put that over 3. I would have 12 over 3. And 4 is my final answer for the long legs measurement. Okay, that's just the long leg. Okay, so if we fill that in over here, I'm going over to the original drawing, and I put a 4 right here. Okay, I know if that side is 4, then that little portion right there is also 4. So what is the measurement of the entire side? Should be 8, right? Because 4 and 4 is 8. So that means my sides are all 8. Now I have something I can plug into this formula here. I'm going to put it over here. Area equals the apothem times the perimeter. So let's figure this out. So the area, the apothem is 4 times the square root of 3 over 3. And the perimeter is going to be 8 times 3. So we'll have 24 here. See if I, hold on one second here. I'm going to make sure that I worked this through correctly. Yes, I did. Okay. Excuse me. Okay, so let's figure this out. So we have 24. Remember, multiply just those whole numbers together. So 24 times 4. Oops, 24 times 4. You're going to get 96 times the square root of 3 over 3. Now let's take that 96 and divide it by 3. And you should get, oh wait, oops. I missed part of the, I hope you've been screaming at me the whole time saying, Mrs. Quigley, you forgot something. What is the, I forgot to put the 1/2 here. I'm sorry. Forgot the 1/2. We need to put that in there. That's so important. I apologize. And hopefully you were sitting there thinking, no, you got to put the 1/2. Because that's going to change what I just did right here. All right, so we're going to actually, what it changes is my denominator. All right, so we're going to actually have this over 6. So now divide your 96 divided by 6. You should get 16 times the square root of 3. And that should be your answer. And actually, I see that right over here as one of your answers. Okay, hopefully that makes sense. This video is a little bit long, but there was a lot to take a look at. So I'll try to send it to you. Let me know if you have any questions.